Institute of Information Technology, Noida. He holds a PhD in Computer Science and Engineering from Jaypee Institute of Information Technology, Noida. M.Tech in Computer Science and Engineering in Guru Gobind Singh Inter University, Delhi. With over 18 years of academic and research expertise, he previously served in JSS Academy of Technical Education, Noida. Dr. Upadhyay has published numerous research papers in reputed SCI and Scopus Index journals, international conferences and book chapters. His research interest spans computer vision, machine learning, deep learning, high performance computing and computer architecture. He has contributed significantly to the medical image analysis, retinal disease detection, skin lesion recognition and GPU based image segmentation. He is associated with professional bodies including IREP and ACM research community. He is committed to advancing research-driven teaching and fostering innovation among students. We are truly honored to have you with us today, sir. On behalf of organizing committee, I wholeheartedly welcome you. Now I request you to take over the session.
Good afternoon to all of you. We start the session. Before starting the session, this particular title is Transformers in Speech Processing. In Transformers in Speech Processing, are you getting something from this? What is the specific transformers means in speech processing? Have you used the ChatGPT? I think all of you have used the ChatGPT, right? And various other tools related to your, nowadays it is very common to see the text data. If you want something, you can just write it to the AI tools and the things are come about it. Today, we are going to discuss that this transformer is a deep learning model. Right? How this transformer is to be used in speech processing. Say as an important day-to-day life, we are using, maybe you are members with that particular tool in day-to-day life like that of Alexa. If you say something to Alexa, they are just reverting it or they are just following it. Right? This is a communication by the means of speech with a device, through the device. And the data, which is very, very important for deep learning methods, what is the correspondent of transformers, that is the techniques which are used for all kind of data, not only for the speech, right? Like that of text, which is in ChatGPT, and various other tools which you have to use for text. Similarly for the speech, audio, video, there are various AI tools in which the data is to be transformed. The transformer is one of the deep learning techniques. Why the deep learning is, what is the significance? Anyone of you are working on this particular domain? Why the deep learning is, what is the purpose of it? Right? If we say the AI for a computational task of the artificial intelligence, this is one of the way to see, right? There is a term called machine learning, right? If we say the machine learning, what is the significant words meaning to for an engineer or a common person? Being as a student, what we say, you are learning, right? And if we are giving something as a data form in an input, then machine is also learning. Right? That is also learning. Instead of student, there is a machine. We are having a different ways to learning. Either you can learn through your books, no need to come to the class. I am not saying like this, right? But you can learn by self. And the other way, you can follow a guided person as a teacher or a mentor. Right? And they instruct you, this is the content, this is the way you have to approach for your target results. Whatever the CGPA or the percentage you want, and whatever the knowledge you want from the specific subject. In the machine learning, we are having two of the approaches to learn the machine or to give the input to the machine. One is called unsupervised, that means you can read yourself, right? By any of the way, by the books, by the internet, right? Or if you follow your teacher, then it is a supervised, right? In between the two, there is few of the techniques on which the transformer, on which the GPT and Llama and various other models of the deep learning which are worked on, right? Supervised and unsupervised. Unsupervised, that means you have to do not follow any guidance from 90%, and supervised you have to follow your teacher what he says. In between that, there is a term which is called semi-supervised. Right? Up to some extent you follow your rules, up to some extent you follow your teachers. Right? And you say, okay, I am following because I need the CTP of that, but I need the skill set also. That is a combination of them, right? Similarly, the machine, we are following a one more rule that is called as semi-supervised. And the models which are used for the GPTs and the devices which are trained over it is all majorly of semi-supervised set or self-supervised. Self-supervised means we have to judge what we want and accordingly we behave. This is the correspondent of machine learning, and over it there is a one technique. There are multiple techniques. I am not going to today about it. There is a one technique which we call as deep learning. That is an extension of neural network. What exactly the neural network is? It is inspired from human brain. Right. What we think, accordingly, what we perceive, the brain can process it, give it to you, and you can see the output. What is the input and what is the output? Say as an example, if we are using a visual set of scenes, what we can see from our eyes, the signal goes from retina, process in the brain, one particular region of the brain which we call as visual cortex, and that process it, give it to back to the front lobe, and you can see the object, right? This is how the processing happens in one particular section of the brain, which is a 300-gram organ and having 9 regions, right? In deep learning, the follow the rules based on that particular scenario of neural networks. When we want something in more deeper side of neural network, we call as deep learning, right? What is important when we are dealing with deep learning, that is data, computation and algorithm, right? The first important thing, what you can pass to the information, right? The second important thing, where you have to compute it. Nowadays there are a lot of things of the data is very large, there is a scope of big data, right? Or if you are dealing with the electronics students, you have to use your mobile phones and some portable devices, low power devices, and you have to put the machine learning in that particular scenario, right? You don't require a bigger model. But if you are managing a large data, you require a high computation machine like our servers. Computation is an aspect according to your usability, right? The third important thing you are going to follow. We are having three things. The first important thing is data. The second important thing is where you are going to execute. The third, how you are going to execute. And the third is correspondent of machine learning and deep learning technique. That is a field nowadays are in every era of electronics as well. Now, if you can see this chart, if we say AI and there are tools, in the machine learning there is a subset of it, that is a computational method which we have to use for AI. And inside of it, if we go in deeper of it, then there is another section, especially not of all the techniques of machine learning, only of the neural net, which we call as deep learning. How where we have to use promptly the deep learning is either what we listen as a speech, or a audio, or a visual data by the means of eyes. We can handle these types of the data or a text data, right? Either a text, either a speech, either a audio. That is all these kind of data. Deep learning is promptly used. You are not going to extract the information from it. What we are doing in the machine learning, we have to process directly, right? This is the image which are OCR image. You are going to give the examinations, right? You are just scanning your answers and then give the result, right? Everything is to be done by the machine, right? How it's happening. So this is how the happening is an example of handwritten text recognition. It is a case of a deep learning and very famous model which is to be used for the visual data is convolutional neural network, right? The person who gave this concept is called Lee, right? And they are managing our lab, right? MNIST, M-N-I-S-T. The data belongs to that is 16,000 images, right? But this particular information, if they want to process it, how they are going to process it? That is a very huge data, and that is the requirement of deep learning techniques, right? We are not going to extract the information. We have to reduce that time. We just pass these images and process it by the model. For the visual information, there is a convolution neural network. Right? The machine is there, they just detect what is inside of the data. How they can analyze this information? The question is this. What the convolution? The convolution is a term of ECE. Is it or not? In simple part. What does it mean? See, the interaction is very good. The things are. What is convolution? The first important concept, we have the properties of this convolution for a neural network. Right? That's why we say convolutional neural networks. In signal processing, there is a concept of bounded input, bounded output. If the large data is there, we don't require anything which is out of scope. Right? On the basis of this theory, there are certain properties of the convolution. Right? We have that if you just rotate the image, if you reduce the size, they are invariant to it. Right? If you reduce the size, not crop the image, you have to scale the image. There are two different things. Right? You have to scale the image, rotate the image, and these particular properties are well handled by the convolution. And on the basis of that, the CNN technique of deep learning can managing these things. In machine learning, how we are going to manage all these things? We are extracting this information, store it in a form of vector, and process it. Right? But in deep learning, no need of that. The system, the function parameters which we have to pass in Python or Java, whatever it is, we have to give the input as in size of the image. The filters which are process the image, and if there is a color, then we have to specify the channels of the image. right? Along with that, if there are multiple filters, one more parameter is number of filters. So we have just process it and without any extraction of information, we are just, so this is the information which we are dealing with, the scale value at 0.1, 0.7, that is of classification that we are taking is. We are just saying that this data is 0.7, that means it is close to the target value, that is 2. Right? We are keeping one threshold. If it is 0.7 more, then we can say that there is a character, handwritten character as 2. If it is 0.1, neglect it. If it is 0.2, neglect. 0.3, neglect. There is a threshold. Like this, we have to set the labels. So another name of the machine learning is function approximation. Right? The function, what exactly the function is? The function is whatever the task you are going to do is a activity or a function. What input you can pass, process it and generate the output, like that of mathematical function. Right? There is a function f, you can pass the input x or x1, x2, x3, generate the output y. So this is all functional side, and if we say this particular image is having a pixel values which is in the range, they are not floating points, they are all these are all you can say initial values are 0 to x for a base case. That's why they are writing as real value over the right? Labeled for output target values for 10 classes, 0 to 9 characters. Right? The pixel intensity is from 0 to 255 and output is of 10 labels. We want to access the what is there in the OCR image as a digit, that is 0 to 9. 10 class labels are there. This is also known as function approximation. Before coming to the transformer, I'll just discuss the visual side. Before coming to the speech, I'll just discuss the visual side or a visual data. So what is the classical history or the background? You have to deal with, right? Being as a the story starts from the neural side, right? And 2010, ACM Award University, that is all the father of deep learning, Jaypee, right? The Canadian, in 2010, they developed one visual data based model which we call as CNN with the person of Jaypee, right? And Russell. So they are just developing a model. If you just see the story of it, electronic brain, perceptron, ATAL, these are all machine learning. Then there is one important model which is for machine learning that's called support vector motion SVM, right? And after that, deep learning. So we can say there are certain models. How can we use that? These models. Model is there for your task. You can use it because as they are pre-trained with some activity. When you are running this code over your data, that is called as pre-trained. How to set it? That is all parameter tuning. When you pre-train it, that is the requirement of change your parameter according to your data. In the neural network, there are two things. First, input with weights. You can change the weight for your data. That is not parameter. So after 2010 to 2025, a lot of homework is to be done in speech also. When we are dealing with the speech, we are dealing with the sequence data. Right? In a sequence data, what is there? We are having the different kinds of data, like we are doing the task of recognition, right? We are doing the task of music generation, sentiment analysis based on speech, right? Identifying the singer, who is the person who is singing this song, that is called speaker identification based on voice patterns, right? We are having that many things. Along with that, there are certain applications which are used for sequence data based model. Right? So sequence data includes the DNA samples, machine translation, conversion of one language to another. Right? Now you can, all of you are seeing the web series, is it or not? And you just transform in your language, right? We can see, okay, this is in Tamil, whether it is available in English or Hindi. That is all translation. Machine translation, sequence data is majorly used for the machine translation. Right? We are just translating nowadays, that is a big set of things. Video activity recognition. You can see the cricket also. Right? Third umpire decision. Umpire not able to see what they can see from the video sound. Frame by frame. So that is all video recognition. Right? This is how the video activity recognition is done. If they are not able to access the video, what they can see? Frame by frame. Is that clear? If you have a question, you can ask the question between now. Name entity recognition NER for this transformer is made primarily in 2015. Right? Say as an example, told to the Alexa, play some joke related to Indian politics. The Alexa plays some joke. That is all based on their knowledge. They just collect the data and frame the joke. Right? This is all causal inference. Right? If you can say, if I ate one apple or two apples a day, what will happen? From 1 to 2, if you are just adding one more apple and ask to the Alexa, what they say is, this is an arithmetic causal inference. Right? This is how the name, instead of name, we can say that this is not only the one person, there can be anything, can be a number also. Right? The name entity recognition is very, very important. That here in this case, Harry Potter is the corresponding name, and we recognize that person, and on the basis of that, we can see them. The data which is there is of music generation and sentiment. After seeing the movie, you can just give the rate, right? Related to story, related to acting. This is also the concern of sequence data. The sequence data, where it is used, that can be used in text. You just give the rating, or for the sentiment analysis, or for the speech. Right? Nowadays, JIIT, there are voice prints also. You can just speak and they'll just find out. Right? This is the deep learning model which is used primarily for the different neural network, right? So this is for natural language processing, we can say, language. Either a visual based models, either a natural language based model. We are just categorizing the two things. What we perceive, what we can see, what we can listen. This deep learning is divided into two of the subsets of the model class. One is for visual, another is for listening. Either you have to use speech and audio, what kind of data. Right? What is in recurrent neural networks is generally used earlier in 2015 for machine translation. There is a sentence, and if you calculate the things, you can go word by word and just connect this word to the next and find out whether it is meaningful or not. Or if it is meaningful, they are having more than one meaning or not. On that basis, we have to frame a network which we call as recurrent. Right? How many words? Have you checked your documents? Which we call as plagiarism report. This says, please fix the sentence, how many words are there in the sentence? You say 40 words for a sentence. Then check for the 40 words. Right? RNN is doing that kind of thing that they fix the sentence and then analyze what is the meaning of it and whether it is contained or the word is there somewhere, and they just match the sentence whether available in the ontology or not, in the database or not. Right? So for this model, we are having a sentence as a word data which is also to be read based on one by one, and we frame it as a time series. Right? This is a sequence data. What is there inside it? The input layer, there are hidden layer for processing, and output layer is a simple neural network. When we come to the recurrent neural networks, what is there? We are having an input and we are having a state representation which is marked by H. Right? Say as an example, the word can have multiple meanings. That is many annotations. Right? What are the H state? Can be one, can be more than one. It is just revert it, and then if you connect it, whether there is one, if you connect to the third word like this, which we call as biagram, triagram, two words connection, three word connection, and this is a statistical methods. When we club for n, then we use for recurrence relations for and called as recurrent neural networks. We can do this task not by statistics technique. We can put these things into as a neurons of the neural layer and forming a network. And it is named as recurrent neural network. Right? Like this. Right? We are just giving the word sequence. First word at time t, t1, t2, t3, like this. The sequence data is time series data. Is that clear? If you have any question, you can ask. There is a concept. This says cannot handle sequential data, consider only the current inputs, cannot memorize previous inputs, loss of memory information, does have use for itself. What does it mean? In neural networks, whatever the input comes, they just, that is called as feed forward. Then there is a term called as back propagation. In that particular situations, when you say the sequence data is time series, then the things are going to transform by a context. We call it as context vector. C will be the mark of it. Say as an example, if you are reading some sentence, it should be meaningful. They have some context. That is called as context. With the base of annotation, they are just finding out whether it is meaningful or they have multiple set of meanings. Right? In that particular scenario, the C mark here, B is the input, A is the respondent. We just find out the connections as in, and the output resultant input is X and output is Y. The architecture of RNN, we are just skipping these things. Right? We come to the main point. 1 to 1, 1 to many, many to 1, these are all types of recurrent neural. Right? Music generation. Changing the note, there are multiple outputs are different. That is the case of 1 to many. Right? There are, these models are related to many to many machine translation. Right? Language translation. Image captioning, say medical reports. Let's say this person is having this disease, one word, after analyzing the information. Right? These are the things where the recurrent types are to be. These are the things which we have to see for the steps of training of RNN. So we can analyze the things by steps. Advantage and disadvantage. Instead of seeing the advantage, we are shifting to the transformer. This is the extension of RNN. Right? This This is a extension of RNN. What next after the RNN? What next after the that next? The RNN, there is a LSTM, and after LSTM there is a transform. Why this particular theory is going to change in last 10 years, or we call it as a previous decade, right? This is, you can see, computational slow, training can be difficult, and the functions which are generating an output for activation functions are not well for the specific set as they are compatible with ReLU, TANH, and few more. And but in case of, they are not comfortable, sorry, for ReLU and TANH, and they are giving a problem of zero gradient, right? What is zero gradient? If you are just reading the information without knowing what exactly the content is, right? This is happening when we are getting an output by these activation functions. You just pass the sentence, these activation are and these sentences are to be break up into words, which we call as token. You give the activation function as an input. F is having a behavior of exponential, ReLU, TANH, stack. These are like the one function, right? And generate an output. Right? This is if you are using these two functions, right? Rectified linear, ReLU stand for rectified linear, and TANH you are well versed with the signal processing. When you are using these functions, there is a problem of zero gradient. You are not able to understand the meaning of sentence, or they are giving some other meaning. In that particular scenario, we are having a zero problem. They are called as exploding or vanishing. Zero gradient is gradient vanishing, right? Exploding means the outcome is not the e to the power x, right? So this is exponential. Output is not controlled. Exploding gradient or vanishing gradient, irrelevant out of information. Because of these problems, the some computational slow, because they are storing every information after 2 words, 3 words, 4 words, every time they are storing, and they say that after 14 words this is the meaning. Or if you are checking the plagiarism after 14 words, the sentence is available somewhere else. Right? Meaning of zero, that's why I have said vanishing gradient. The weight of earlier here can be of zero, right? Or you are not getting any output. If you are iterating too many times, doesn't matter. The iteration stops after few. If you say I can check my learning technique at 5 steps or 5 epochs, whether it is okay, maybe they are not going to give you the correct output at 5. You can go up till what extent when you are getting the accuracy is constant, right? The iteration is based on constant behavior. If there is a iteration stops early, there is a problem of vanishing gradient also. The exploding gradient is also in training. When you are training the machine, and if your training is not perfect, they are not going to give you the answer. Right? First you train the machine. If the teacher is giving you the right content, then only you can write the right value in the examination. Right? So this is the same story. If you are train the machine properly, you can answer the things properly. This is weights becomes unexpectedly large, then exploding, and gradient value is max in the probability, that is 1. You are keeping the weights in between, not in the extreme value, not at 0 or not at 1. When you are doing the machine learning or a deep learning model for any of the specific task of data as a text, speech, and there is another model after the RNN for a sequence data that is called as LSTM, right? That is called as long short-term memory based model. Again, they have the problem that they are used for the fixed length, 14 words, 15 words, right? Fixed length, if we are analyzing these things, we have first to store it and then process it. There is a problem of vanishing gradient in the LSTM, right? how to do that? They can divide the things into small chunks and process the things. Multiple factors, that is called as time and LSTM, is one of the category which can manage the things nicely, but not up to that extent. Right? So what is there in the LSTM? In the layers, they are having some gate concept, right? We are having three of the, you are having input gate, output gate, and forget gate. To managing this activity of vanishing gradient and exploding gradient, right? Up to such some extent they are managing, but not much. What is the important thing for RNN and LSTM? That they are robust, but they are very slow in computation. Right? They are storing the information, which we call as temporal dependency. Temporal means time is what input they are passing, they just store it and then process it. We don't want this thing. We want a model which is efficient, dynamically handle the things, right? And that's why we can shift to the next state, that is called as GIIT, gated recurrent unit. Again, they are having a gated concept, and we are having two of the gates. They can reduce the some abnormality of LSTM and handle the dynamic set of things nicely as compared to these two methods, right? So this is one of the model which is used in transformer for visual information, that is called as VIT, that is called visual transformer, right? After LSTM there is GRU, and after GRU there is a transformer. Transformers can be of various types of transformer nowadays based on data or hybrid data. Right? Who give this motivation that if the tax length is not fixed, then also you can give the meaning of it. Right? There are certain persons which are developing a model of transformer, right? In 2015, Bandinu and Yugon, these are the two persons who are giving this model, right? This is no need to store every information in the memory, right? If you are in the virtual environment, usually you are using VL, right? Or then it is necessary to store everything. This is, if you are doing this, then it's a very slow system. How to handle this problem? This is, if the length is changing, dynamically changing, not 14 words, 7 words, 6 words, then also we can give the context of it, right? For a text data. If it is a speech, the things are something different. So there is a computer vision transformer called as VIT, based on their name. Also with this case, there is in 2020, right? The bits is there on the basis of VIT is to be on. Image classification, very famous model, and we use for captioning also, COCA transfer. Semantics segmentation, nowadays that can be used for speech also, right? The speech processing is structure. When we speak something, what is our accent? What is the flow? How many words we can speak in a minute? Everything matters. That is called as prosodic structure, right? Semantic segmentation in speech is happening very nicely, and the area it is for the text, right? This thing is used for the text, right? Object detection. Have you heard the name of YOLO? Right? YOLO have 11 versions nowadays. They are used for the object detection, right? Just to move the camera, you are using the mobile phone, make some images there, right? In your mobile phone, and you just click the photo of the person. The captioning is that this person is having the name this. Right? If you store the person image with that name. Right? So this is how the object direction is to be. Rapid B2G transformer is that. Previous models are in LST and JIIT. Right? Now the stage of transformer which can handle the vanishing and exploding threading problems nicely on a dynamic text or a dynamic speech sample. Right? And it is very interesting if you are working on some other set of sensor networks or any other set of things that can easily applicable. What is important when we say previous model? The distribution of the data. Right? If you want to send your speech sample to multiple persons, that is data distribution. Right? What is, or if you want to do the computation parallel, there is a complete paragraph of newspaper and you want to do the processing in 1 minute. You don't have the time. How to do that? You have to use stacked transform. Layer by layer you can pass the data. Process it in parallel. Parallel processing is happening in transformer and it is quite good for managing the task very efficiently in less time. Computation cost is reduced. That's and there are a few things which is happening inside the transformer. Self-attention. Right? When you go to the corridor, your friend is there. You somewhat stop. They say, okay, I'll just discuss with you. If some other unknown person is there, you say, okay, go. I won't bother for it. Your self-attention is a psychological aspect. You can know that person, you can stop and you can talk to them, or if you don't want to talk, you also see and move on. So this is the attribute of transformer model. They are self-attentive. Then, because of this reason, they are able to manage the dynamic text or number of words limitations are not there for a text. Right? So if we are saying that for text information, so this is that if the name is there or some object is there, int value is there, they can be mapped to the multiple words. There is a very simple story that in sentence, few of the word combinations are by default. Taj Mahal, historical place. Right? No need to map anything. First thing is that this is the name entity recognition is the concern of it. Any other models are there based on that particular thing. Right? We are having the different words which can be easily mapped to the it. If we are mentioning it, that can be anything. Right? This is our positioning of the text that machine can analyze these words for it if it is in the ontology or database. This self-attention is primarily used for language translation. Right? And how they can be managed? So there is a term called BERT. BERT is another model between LST and then transformer. Sorry, it is an extension of this one. Sorry, it is an extension of the transformer. Right? BERT is used for Roman language conversions, English to Roman. Right? Its name is our Romanian BERT model. In 2019, and BERT is bidirectional. Say as an example, if you are reading the sentence, it is not necessary that every time when you connect to the next value is meaningful. This is, if there are multiple meanings, please type the previous word also. Right? And then both the direction you can check it. Positioning in forward and backward. That is called bidirectional transformer. Transformer model is having a bidirectional for text set. For language translation, there is a first word model has to be applied. For and there are other models which you have to or related tasks you are using that. How the cell potential works for a tax bill. Right? What is the meaning of the cell potential? Right? In the morning, you just go to the shopkeeper, right, and ask, I need the bill. What the shopkeeper, the shop person, the owner of the shop, what they say, the bill, what is of full cream milk and oat milk and what category of milk. They just frame all these things. Right? Your query is you require a milk. And what is the key value inside it? Only 1 kg of milk. Milk is the key value. Right? And in this key value, we are having 3 of the category based on the grade level of the milk. Right? This is called as query key value pair. We are just framing the things on the basis of its query. What is your query? What key value inside the query? And on that basis, what are the values? And if you ask them, I need a half-tone milk, then they will provide. Right? The system can check all the values. This is called as QKV. And just break the query into tokens or words and analyze the things as QKV, and then framing a vector which we call as QK transpose. Right? Key value orthogonal, that you have to test this key value over the whole query set. Where exactly is the position of it? Right? And then apply the neural network, deeper insights, deep learning, activation functions, softmax, and transform the output. If you are getting it, it's okay. Otherwise, check another one. These are the factors if you just code these things in the Bible. Right? You have to analyze the things in a form of encoded. This transformer is exactly encoded decoder model. First, what they can say if you are dealing with the text value, what is happening? There are words. They just encode, break these words into tokens. Single words or 2 words based on that. Right? Therefore, framing a tokens, and these tokens is to be encoded in one environment and process it and generate the output. If you don't want to process it, you want the decoding, you just do it. This is encoder and decoder. Scale dot product potential. What I have told you, cell potential or dot product. If you have the key value over the query, that is a dot product potential. Right? This is how the query with the key value, maybe one, maybe multiple. Right? When we are dealing with the big data frameworks like that of Kafka and all other frameworks on, when we run Spark or any other tool, we have to use these particular things in the database, managing the database in a different way. Right? Scale dot product, there is how the computation empirical formulation is there. Right? QK transpose in a denominator, that is a dimension is very important, which is marked here for a key. Is it a single or a 2 or a 3? I just gave the example of having a 1 key as a milk. If there are multiple, right? Say as an example, milk and bread. Usually, you are just asked these things. If you are vegetarian, you say milk, bread, and egg. That is 3 key values. Right? If what is the dimension correspondingly for the key, that should be marked here in the this is what exactly I have told you, the same thing, that is also called as soft match or soft learn. attention is handling the soft learning. What is hard learning? Hard learning is fix the length of the text or a speech sentence and then use the processing. So it is all soft learning. Dynamically they can handle the text or a sentence number of words is not the limitation. This is a term which we call as word embedding. If you give the sentence, you can embed the sentence. Word by word. There is a term called word embedding. When you map the key value over the value. There is another transformer model which we call as multi-hat. If there are multiple key values and you process individually without any relation. Whatever the example I am going to use that milk, bread, these are all key values which are associated. If they are not associated, you can handle it independently. That is called as multi-hat attention and mechanism for a transfer. Is that clear? This is how we are handling these things. We have the multiple case, multiple queries can be possible, multiple case can be possible, right? And multiple values are already there for each of the key. So this is the case of multi-hat attention. This is used in transformer as a mechanism for multiple queries. This is the architecture which we have to use for multi-hat attention. This is functional architecture, right? This is the detailed architecture when you frame the things in terms of Python code as a vector set. What are the weights which you have to assign to each of the values of a key, right? And if you just mark these things, if there are 8 hats, that means you have to see all 8 weights are there, 8 key value pairs are there, that means 8 particular keys are managing at a time for a single query. Multiple queries for a single key, like that. Is that clear? If you have a query, you can ask. For multiple hardware. Now we shifted to the speech. Right? After a lot of tasks, we have to see that how the attention is used for the processing. That many transformers you have to deal with nowadays in the form of frameworks called as Jaypee, DeepSeek, O3, Claude, Gemini, Llama. Right? I think majority of you have used these LLM-based large language models, right? If you are dealing with image or a photo scaling, Canva is more commonly used, which is not there. Like clip, segment, anything vision related issues. Speech, whisper, and voice calls. We are just seeing that where the transformer is used. Right? So they are used in multiple places for multiple tasks. The story behind this transformer model of deep learning is of large language model. Now it is not large language, it is mass language model also. Right? Why the large language model? Because multiple parameters are there. Right? You have to manage that many millions of parameters, and if you are searching for something, you can understand that how much information is there for the Google to give your query answer. Right? That is called web corpus. Right? And nowadays, what they are going to add, very important, not only if you give the speech voice print, they just find out and give it to you. Right? not only you have to type as a text maybe, not necessary, right? Web search is efficient for both kind of data, text as well as token predictions is the same story for the transformer. It's based on the same principle. The only thing is that we are managing the vanishing gradient, exploding gradient problems very nicely, dynamic length of the text and speech signal, or we can say speech cycles. We can divide the word or what you as a format in speech instead of word in a text. Right? What is the reasoning? What is the prosthetic structure? There are a lot of things which we have to say the features of it, right? And apply the reasoning over it by the means of transformer. But when we are dealing these kind of data, we require heavy machines. In the visuals, we are using graphics processing units by NVIDIA. Like there are various in our universities we are dealing with A100 series, right, for the GPU server of NVIDIA. Right. But if you are dealing with the speech, you are following the same concept of supercomputing, not of GPUs. What is one-shot learning, zero-shot learning? That is very, very important. That how much reduce the time for analyzing your query. Right? This learning method is based on in what particular aspect or what particular time you are getting the resultant values. A kind of technique which we call as zero-shot learning. Data is always a fuel for artificial intelligence. Right? In 2017 onwards, it is the person who has seen the transformer is properly handling the task of speech signals, right? And they are used for the variable and speech set of things, right? Instead of and doing the things with various form of devices which you have used, like Alexas. And the one important thing is variable length, another is parallelism. Massive parallelism is there in the transformer of handling. If you are, suppose you are the candidate for the election, right, and you want to transfer your message to the whole Mysore, how to do that? This is all you require which are able to distribute the things on the basis of massive parallelism. Transformer is a deep set of things which can manage this thing. LSTM is part of it. These are certain set of while transformers are good for the speech, self-potential capturing a long range context. Right? Fixed time is one issue, another is if you have a very last sentence. Especially speech is a random signal. Long context is a problem in that context. Right? The speech, in case of the speech, the transformer can manage these things by the means of self-potential very nicely for high parallelism, handling variable length audio like that of text. You can take 7 words in text, similarly 7 formats in speech, or 10 or 15, they are not much bothered. Feature representation. If you are handling the speech, you are dealing with a spectrogram. There are various tools to see that how the voice rate is changing the signal pattern. We just plot it in a form of spectrogram, and we in a form of row waveform. Superior performance in ASR, automatic speech recognitions, or speaker identification for the cases. One model which is very famous based on transformer nowadays is to be used, that is called as conformers. Right? This conformer is a mixed hybrid model of natural language processing and vision. What they are doing, this is self-attention is globally or locally. Right? If I don't want to, if it is a long sentence, if we don't want to read the complete sentence, I am concerned with the subset of a sentence, we can see that. That is called as global self-attention or local self-attention. In control, that can be deal with the convolution of self-attention mechanism combined as a hybrid technique. When we are dealing with the speech or long range context, we have to deal with these many attributes of the speech as prosodic patterns, speaker characteristics, volume, dependencies, use, localism. What is short-term and what is long-term structure that we have to deal in both the cases and dynamically handle both the things very nicely. That's why it is there for the speech process. Secondly, the major problem for the random signal of speech, whenever we speak, maybe on the background noise is there. How to handle these particular things as what for a sequence data, long distance or passing frequency and these other data applications. When we are training the formats, we have to analyze the features out of the speech as, and we just make these features based on temporal data, and we make a frame of some extent by the IEEE standard using a technique of VDFT, right, of 10 milliseconds, right. This is how the delay is to be marked over of 10 milliseconds, and we just train in one vector of formats of FNL. We are working on that particular scenario. You can see how we are applying this formats and put it into this attention framework for computation and just find out the attention score. And generate the frame output as some meaningful outcome. This is how the things are happening. Whenever we are dealing with a multi-eye version over the speech, we are concerning these many features. Feed forward network, conditioning of reading, serial normalization. When we are talking this encoder decoder set of things. This is the major attributes which you have to see for speech. Remove sequential dependencies, self-attention on all frames at once. And what is the story behind these particular 4 points? The first and important, when you do the parallelizations, you have to divide the speech signal into different parts, say as a long sequence of sentences. If you say you have to record the speech of Modi, that is of maybe of half an hour or 1 hour, you are not going to process everything. What you have to do? You have to make this video. And you want to process that out of the, which is any important significant thing for middle class, then you have to figure it. And do the processing of these sub-sentences or sub-speech sections independently in a parallel way. This is the meaning of self-attention multi-hardware transformation. It's using the when we are doing the one-way chart and parallel distributions, we are using a feed-forward neural networks with that. This is the same set of things we have to do. Basic attitudes, what we have discussed. If you have any question, you can ask.
LinkedIn and other social medias, there are ton of AI generated data. When the AI is trained on its own AI generated data, is the inference useful or is it the AI?
See as an example, you are saying that AI data over AI data.
I put some, people put some AI generated data on social medias. Right? And when AI companies train their AI on these AI generated content, is
I
there?
understand. That is called as synthetic data, right? That is not a actual data. Machine has generated that data, and over that, if you apply the AI, whether it is meaningful or not, your question is right. It is all depends upon you are dealing with the synthetic data. You just check it out. If data is unbiased, what is the meaning for use again the synthetic data? We have a few models related to that. That is called as GAN, generated universal network, right? Which can check that data is either actual data or a synthetic data. So first, you can pass to the GAN. If you have the actual data of that data, just check it out. This is this data out of this. How much is synthetic? And then do the processing. First, check the data by the means of GAN, and then process it.
So it's not useful.
Regarding the usefulness, is all depends upon the person to person, right? If the data is completely synthetic, no need. Any other question?
How to deploy these models into real-time devices like mobile phones or cases?
There are frameworks and there are phones. Android is there. There are certain languages which you have to use, either Java, you can easily use. You can deploy these things on your devices. There are certain frameworks which you have to use Java based. For a device integration, nowadays earlier there are certain issues, right? Like the issues of you can say high performance issues. And in that particular scenarios, nowadays there is integration with here as well. Any other question? This is the current generated model which is used a lot in current scenario. That is called conformal and model having a Python that is made to sequence. Rest of things we have discussed. If you have any questions, you can ask. Any specific things you are doing in your projects, or if you have either a sensor networks or an IoT or like applications from the device reporting. No question? Thank you.
Good afternoon, everyone. As we come to the conclusion of today's session, firstly, I would like We truly appreciate your time, effort, and expertise shared with us. Thank you, sir. With this, we have reached the end of the faculty development program. At this moment, I kindly request the participants to share their valuable feedback on the FDP.
Good afternoon, Honorable. I am Jaypee, Assistant Professor Department of CSE from Franco Institute of Technology, Tamil Nadu. First of all, I would like to thank the organizing team for providing the opportunity to attend this wonderful FDP on speech processing in hearing aids. From the beginning, all the sessions were very clear and informative. We started the session with anatomy of ear and then deep dive into how signal processing happens inside the cochlea and in hearing aids. All the sessions are very clear, and especially the session on AI was very informative as I am from CSE background. Thank you for all the sessions, madam. And we had an opportunity to visit the industrial All India Institute of Speech and Hearing, where we had an opportunity to see different types of hearing aids, IAC, CSE, rechargeable, so and so. And software demonstration given by sir was very useful because it is something usually you don't see everywhere. And the hospitality is too good. Thank you. I wish the team to conduct more sessions in the future. Thank you. Thank you, ma'am.
Very good afternoon. Myself, Jaypee from West Indian College, Nagpur. And yes, we had a wonderful collaborative, learning, knowledgeful 6 days FDP. I know it's very difficult for the organizing team or maybe the coordinator, how much efforts they have to put, mainly for documentation and all those things. Yes, it went on very well. These 6 days, starting from the inaugural functions where they have addressed with how and why these speech hearing aids are important. And Ajit Kumar sir, Sharad sir, Shokrav sir, even today's sessions, Pawan sir and Ayappa Swami sir have started with the anatomy of the ear and went on with how processing techniques, the DSP, DCP techniques will help us to enhance the speech recognition. And also with the industrial visit at eyes, we come to know the different types of hearing aids and why it is important for the Gen Z, what we call, so how it is going to impact their ears by using the earphones or earpods. So these all things we are able to know during these 6 days of FDP. And it was really knowledgeable and insightful. Other than that, the accommodation, the food stay, whatever we had in these 6 days was very a happy stay, we can say. And we got a chance to visit this heritage Mysore city in the evening. We visited all the nearby places. Thank you for that. Yes, if such collaborative activities, if it is being done in future, we are very interested to be part of this. Thank you all.
Thank you for your valuable feedback.
Hello guys, I'm Varun and I'm still a student studying MTech. And this program, initially we thought that getting into this program is like quite advanced and we are not found out. Like we are not into these topics more frequently. And coming from EC background, it was quite informative for us, and we did have a good time here. All the sessions were like smooth going. And the thing I would like to highlight is that the industrial visit obviously, and along with that the request is that in the group making criteria, all of us the tech people were kept separate, and all the professors were kept separate. My expectation would be that if you could collab us too with them, it would be like interesting criteria to be interested in, and that that would have increased span of learning. And thank you guys. Thank you for the time.
Thank you, Varun. Now, on behalf of organizing committee, I would like to extend my heartfelt thanks to Dr. Chandrasekhar Empati, Professor and Head of the Department, for his constant support and guidance. Also, I thank Dr. Nagaraja PG and Professor Mohammad Anis for successfully organizing this activity. Also, I take this opportunity to thank all the coordinators for the dedicated efforts and all the participants for your active participation throughout the program. Once again, thank you, Anil. And those who have not completed the feedback part, please complete it now.